Hello, thank you very much for the presentation, for your attention. So I will present you today advanced manufacturing of electronics for space applications. This is the work, the efforts of my colleague Rita Palumbo. Unfortunately, she would have loved to be here, but she's on sick leave. So I'm just part of a team. I will do the presentation on heavy half. Small outline of my presentation is just we'll do a quick introduction to the concept of advanced manufacturing of electronics, which I think everyone is aware. I will describe the European Space Agency vision on AME. Also describe the challenges, what are the gaps to be filled until we go there. And my presentation will be focused especially on ESA internal roadmaps and R&D activities that we want to start. Some of them started already, want to start soon to develop the next generation of electronic components for space, and also some conclusions. So, of course, I think everyone knows here what is understood by advanced manufacturing of electronics. So it's not only about additive manufacturing, 3D printing, which is, of course, a big, important part of it, but it's also about cutting-edge, innovative manufacturing processes. I'm thinking about hybrid packaging, flexible electronics, new novel materials, etc. So everything as a whole is what we call advanced manufacturing of electronics. So let me do a small introduction about the European Space Agency here. Of course, please forgive me if I tried to explain all the funny space-related acronyms here. Also some QR codes which you are happy to explore if you want. So the European Space Agency is an intergovernmental organization, it's public. We have 22 member states, cooperating states, associate members, you can see listed here. We have several facilities in Europe, in Guyana. The main technical center is in Estec in the Netherlands, where I'm based. But we also have 2 centers here in Germany. We have the European Astronaut Center in Cologne to train the astronauts. We have the ESOC in Darmstadt to allow for operation of spacecraft. So the way ESA works is that the 22 member states provide funding to ESA, and ESA returns up to 85% of this in geopolitical return policy, so proportional number of contracts proportional to the funding of each country. The aim of ESA is to build spacecraft, put them to space, to investigate. How do we achieve this? Part of this is by fostering R&D activities. So what are the next generation of materials, units, systems, also Tripoli components? And this is achieved by several ESA funding schemes. So we have, for instance, the technology development elements, which allows for what we call in space a low TRL, so technology readiness level, which is in a scale from 1 to 9, from proof of concept, design, manufacturing, testing for reliability, and space heritage, which is 9. TD is a mandatory program for all member states and allows for lower TRL. Then a next level will be by the GSTP, so General Support Technology Program, which is an optional program for the member states and allows for 3 elements, depending on if it's industry taking the initiative to try to develop an idea, a new concept, or if it's ESA that publish an ITT, invitation to tender, because we are public, and then any users can bid for it. There are many other programs, depending on the application, for telecommunication, artists, navis for navigation, etc. All of them are published here in the ESA STAR system, so system for tendering and registration. You are always free, SMEs, companies, big users, academia, to register here and to access the ITTs, so you can bid. Or we also have some years ago the OSIP platform, Open Space Innovation Platform, in which anyone can submit an idea, and in a sort of social media environment, users of the community will assess that idea to see if it's worth to go for it and build it. So the presentation is all about the path we have been going in order to achieve a compendium of a lot of new R&D activities that will be published by the end of the year. So what is our vision here? Why we're starting? So Rita Palumbo started a couple of years ago working on this for AME of electronics, but we are not the only ones. Many colleagues at ESA have already been working a lot on this. For instance, for